In the last video, we looked at one example of finding a confidence interval for a population mean. In this video, we'll look at a second example. This example is going to be on estimating the mean monthly discretionary income of households in Riverside County. This is similar to 9.2 numbers 27 to 32 in the textbook. The Melinda Rosewood Foundation recently conducted a study to estimate the population mean monthly discretionary income of households in Riverside County. And what's meant by monthly discretionary income is the amount of income left over after somebody pays for all necessities. So after housing, transportation, food, taxes have been paid, the leftover amount is discretionary income. And in particular, they're looking at how the monthly discretionary income in households. The Melinda Rosewood Foundation obtained a random sample of 81 households in Riverside County and determined the monthly discretionary income of each household. After determining the monthly discretionary income of the 81 households, the researchers calculated the sample mean to be $265 with a sample standard deviation of $74. Part A says identify the point estimate for the population mean of monthly discretionary income of households in Riverside County. The point estimate for the population mean is the sample mean. And in this problem, the sample mean has already been calculated. The researchers calculated it to be 265. If you were the researcher, then you would have to calculate this on your own. You would have your sample data, and then from that sample data you would calculate the mean and the standard deviation. But in this problem it's already given, so we know that the point estimate is 265. Part B says a histogram of monthly discretionary income of households in Riverside County shows that monthly discretionary income is highly skewed right. Explain why a large sample size is needed to construct a confidence interval for the mean monthly discretionary income of households in Riverside County. So discretionary income is skewed right. The histogram might look something like this. And that's important to know because if it's skewed right, then it's not a normal distribution. Remember that in the requirements, one of the requirements was the normality condition. And that normality condition said that either of these two things have to be true. The population must be normally distributed, or if that's not true, the sample size must be large, and in particular it must be more than 30. If monthly discretionary income is skewed right, that shows that the population is not normally distributed. So this condition right here is not true. I guess we could cross that out. And because that's not true, that means that in order for us to meet this requirement, the other option must be true. So it must be true that the sample size would have to be sufficiently large, more than 30. And the reason that your sample size has to be more than 30 is that that will ensure that the sampling distribution of X bar is approximately normal. And this relates to the central limit there. So in part C, it says that in 2018 there were approximately 120,000 households in Riverside County. Explain why this fact helps to ensure that the requirements for constructing a confidence interval are satisfied. This information tells us the population size of households in Riverside County. That capital N is 120,000. Knowing capital N and also knowing our sample size of 81, you could use these two facts to verify the requirement for independent trials. And that requirement can be checked by verifying that this is true, that the sample size is less than 5% of the population size. We could put in the values for N and capital N now. Multiply 0.05 times 120,000. We'll get 81 is less than or equal to 6,000. That's true, which means that it is true that N is less than or equal to 0.05 times capital N. And in effect, that means that it's true that the trials are independent. Part D says determine and interpret a 90% confidence interval for the mean monthly discretionary income of households in Riverside County. There are different ways of calculating this confidence interval, and as always, you can use any method that you prefer. You don't necessarily have to know all of these methods. One method is to use the formula and the t-distribution table, table 7. And if you're doing it this way, the first thing you would do is to calculate the margin of error. In this case, use this particular formula. We know what S is. The sample standard deviation is $74. The sample size was 81 households. The last part to this would be the t sub alpha over 2. And remember that that represents the cutoff t statistics for the middle 90% of students' t distribution. One way to find the value of t sub alpha over 2 is to use table 7. And as always, it helps to draw out that t curve. So I'll go ahead and draw that out. Draw this flat curve. The middle part of that curve is 0. This is 90% confidence, which means that it's based on the middle 90% of our t distribution curve. Or in other words, that middle portion has an area of 0.90. The alpha, remember, is the area of the tails. And that's the leftover portion, which is 10%, or an area of 0.10. So one tail is going to be half of that, alpha divided by 2. So it's going to have an area of 0.05. Same with this tail over here, it has an area of 0.05. To use table 7, you need two pieces of information: the degrees of freedom and the area under the right tail of the curve to the right of t sub alpha over 2. Degrees of freedom are n minus 1. In this case, that would be 81 minus 1, which is 80. The area under the right tail is 0.05, based on this drawing of the curve. We'll go to table 7 and look up that t value. Let's see, here's the area in the right tail of 0.05. Over here we'll look for the degrees of freedom. We need 80 degrees of freedom. That's going to be down a ways. Here's 80. And the area of 0.05 was starting here, and I'm going to follow that down to the second part of the table. Still following that down, and it looks like it's right here, 1.664. So for 90% confidence and 80 degrees of freedom, our value for t is 1.664. Plug in all those values into the formula, and the margin of error comes out to 13.68. So the margin of error is $13.68. Remember, the units here are in dollars. This means that we have high confidence that the population mean could be as much as $13.68 higher or lower than the point estimate of $265. So finally, we'll calculate the confidence interval. We could use this formula for the interval, point estimate plus and minus the margin of error. So 265 plus and minus the margin of error of 1368, and the lower bound comes out to 251.32. The upper bound comes to 278.68. So that is the confidence interval. Another way of finding this confidence interval is by using a graphing calculator. If you use the Casio, you'll want to use a function called 1s. If you're using a TI 83 or 84, you'll use a function called t-interval. In these lecture notes, I have the steps for each of these calculators. Here are the steps for the Casio. Go to your stat window, go to the option called enter for interval, then choose the option called t, and then you'll find 1s. You put in variable for your data. Your confidence is 0.90. Put in the mean, standard deviation, and the sample size, and then put execute. And on the TI 83 and 84, go to your stat button, go to the tests option, scroll down to the function called t-interval. You want to make sure to put it in stats mode. Put in the mean, standard deviation, sample size, and then your confidence level of 0.90. And you should get this result, which is very similar to the result that you get using a formula. The interpretation of this is that we are 90% confident that the population mean of monthly disposable income of households in Riverside County is somewhere between $251.32 and $278.68. Alright, in the next video we'll take a look at the last parts to this example.